Good morning children, this is Nageshwara, IIT Chemistry faculty. Let us continue, our topic is nothing but atomic structure. Okay, already in the previous class we discussed about the discovery of electron and discovery of the proton. Now in today's class we are going to discuss about the third important subatomic particle or fundamental particle is nothing but neutron. Okay, who discovered this neutron means James Chadwick discovered this neutron. James Chadwick discovered this neutron. Actually, discovery of neutron takes place nearly 50 years after discovery of electron and proton. There is a reason behind that, that is nothing but proton and electron are easily deflected by either electric field or magnetic field. But here the problem behind this discovery of neutron is nothing but it is not deflected by either electric field or magnetic field. That's why it took nearly 50 years after discovery of electron and proton. But finally, James Chadwick discovered neutron. Okay, by doing one experiment that is nothing but he took alpha rays. He took what ma? Alpha rays and he bombarded with the beryllium atom. Okay, he took what ma? Alpha rays. Alpha rays means nothing but what? Helium particle. Mass number 4. Already you know the indication of the atoms. Atomic number and mass number. And he bombarded with the beryllium particles. That time what happened means he observed that that time he observed that some type of energetic rays are coming out from the experiment. While he is doing experiment, he bombarded with the alpha particles with the beryllium. Then what happened? Some energetic rays are coming out like gamma rays. But here the problem is these rays are not deflected by either electric field or magnetic field. There is some confusion what happened this one. Okay, that means finally James Chadwick conclude that the rays which are obtained from this experiment are chargeless particles, but they have some mass. These are massive particles but without having any charge. And finally he named as those particles are nothing but what ma? Neutrons. But these are chargeless particles but contain some mass. Okay, this is about the discovery of neutron. And who discovered neutron? James Chadwick. Let us see the structure of the atom. This is for your identification, not fun. See, observe this one. This is how the atom is present, and these are the electrons which are always revolving around the nucleus. This is called nucleus. The central part of the atom is called nucleus. This and all we will discuss in the upcoming classes. In this nucleus, what are present? The two important one, protons and neutrons. Protons and neutrons. Okay, fine. After discovery of this neutron, so many scientists, they are trying to explain the internal structure of the atom. The internal structure of the atom. Okay, these three important subatomic particles are present. Where these particles are present, how these are exist. Let us, like that, so many experiments done by the different type of scientists. Okay, some of them are failure, some of them are succeed in their experiments. Okay, before going to discuss about the atomic theories, let us discuss about the properties of the three important subatomic particles. Okay, what are the properties? That means their mass number, what is the charge value, we'll discuss. Okay, the first one, properties. Okay, first one, electron. Next one, proton. And next one, neutron. That means briefly we are comparing the properties of the electron, proton and neutron. The first one, electron was discovered by, who discovered electron? J.J. Thomson. Who discovered proton? Goldstein. Who discovered neutron? Chadwick. Don't get any confusion. This is very important. Who discovered electron means J.J. Thomson, Goldstein. And who discovered neutron? James Chadwick. Just remember, these are very easy. Don't confuse anything here. The second point is nothing but, you know, electron is what charge? Negatively charged. Negatively charged. What about the proton? Positively charged. What about the proton? Positively charged. What about the neutron? Chargeless. There is no charge. Chargeless. The third point is nothing but, if there is a charge, therefore it contains one value. That value is nothing but 1.6 into 10 power minus 19 coulombs. That means the charge of the electron is nothing but 1.6 into 10 power minus 19 coulombs. This is the charge of the electron. Here I am going to keep minus. Don't be think this is nothing but minus 1.6. It is not minus 1.6. The charge value of the electron is nothing but 1.6 into 10 power minus 19 only. But this minus indicates it is negatively charged particle. Same like that only. Okay. Or one more value is there. That is nothing but 4.8 into, this is in coulombs. Okay. 10 power minus 10 ESU. Electrostatic units. You can use any units, either coulombs or ESU. Normally we will say charge in coulombs only, but if you want to write, you can write minus 4.8 into 10 power minus 10 electrostatic units. These are the two units which you are using to calculate the charge. Same like that only, the charge of the proton also 1.6 into 10 power minus 19 coulomb. Same value only, but the charge is different. Or plus 4.8 into 10 power minus 10 ESU. Electrostatic units. What about the charge of the neutron? Is 0 because it is chargeless particle. There is no charge present in the neutron. Okay. Next, the fourth one. You know, all are having some mass. All are masses particles or not? Yes. Then what is the mass of the proton? What is the mass of the electron? What is the mass of the neutron? You know, atom is smallest particle and which we cannot see with our naked eye. Then think about the mass of the atom. Very less. It is nearly equal to 0. Then think about the mass of the subatomic particles. Whatever may be the value, we need to consider. What is that one? Electron mass is 9.1 into mass. 9.1 into 10 power minus 31 kg or 9.1 into 10 power minus 28 grams. What is the value? 9.1 into 10 power minus 31. 10 power minus 31 is nothing but 0.000000. That is 31 zeros. That much smallest particle, these subatomic particles. Now let us see the mass of the proton. 1.672 into 10 power minus 27 kg or 1.672 into 10 power minus 24 grams. That means when compared to the electron mass, proton mass is somewhat more. Then think about the neutron. Actually, the mass of the proton and neutron is similarly equal. Nearly equal, but not the same. When compared to the proton mass, neutron mass is somewhat more. That is nothing but mass is equal to 1.672 into 10 power 675 into 10 power minus 27 kg or 1.675 into 10 power minus 24 grams. See, nearly equal, but which is having more mass? Neutron only having more mass. Then the last and final point is nothing but relative charge. Relative charge. Relative charge is nothing but electron minus 1. The relative charge. Here the relative charge is whenever if they ask in any type of examination what is the relative charge means, you just take +1. Here no charge. Okay, relative charge also what? 0. Okay, this is about the comparison between the properties of the electron, proton and neutron. Electron, proton and neutron. Let us discuss about the next one is nothing but atomic models. Okay, the next one, atomic models. That means to know the structure of the atom, so many scientists they done different type of experiments to find out the internal structure of the atom. To find out what internal structure of the atom. How Dalton explained atomic theory, same like that only the remaining scientists also they started their experiments to know the structure of the atom. The first one is nothing but J.J. Thomson atomic model. J.J. Thomson atomic model. Atomic model. I think you know about J.J. Thomson. He is the scientist who discovered what electron. Okay, who discovered electron? J.J. Thomson. And moreover, you need to remember one important point. At the time of J.J. Thomson, there is no discovery of neutron. Only two particles are present. Those are nothing but proton and electron. Already we discussed in the starting, discovery of neutron takes place nearly 50 years. That is why in the time of J.J. Thomson atomic model, there is no point of what neutron. Okay. Therefore, the first one. Okay, what is this J.J. Thomson model? Actually, J.J. Thomson trying to explain the structure of the atom by compare with the one thing. What is that one? According to J.J. Thomson atomic model, atom is a hard sphere. Atom is a hard sphere. Okay, he compared his atomic model with one important fruit, that is nothing but watermelon. I think everyone like watermelon. Am I correct or no? Yes. Usually we like to eat watermelon in summer. Okay, it's good for health also. Okay. Okay, if you check the watermelon, in watermelon you can see the red color part. A red color part. Am I correct or wrong? Yes. A red color part. Okay. This red color sphere, he said that a positively charged particles. Okay. This red color is nothing but what positively charged particles, nothing but what protons. And he said that in watermelon there is some black color seeds present. There is some black color seeds. That black color seeds he compared with the electron. That means in this hard sphere red color part, that means in this positively charged particles there is some negatively charged particles also embedded in it. Like this, negatively charged particles are present. Okay, that means in watermelon, how the red color part is present, same like that only, protons also present the whole sphere. And how the black color seeds are present, same like that only, electrons are embedded in it. That means negatively charged particles are embedded inside the red color part. Okay, that is why this J.J. Thomson model is also called as watermelon model. Okay, watermelon model. Or one more name is there, that is nothing but plum pudding model. Plum pudding model, or another name is nothing but Christmas pudding model. This is only pie pudding. That means You can see plum pudding means like cake. Okay, cake is present like this, no? In this cake, it is decorated by some type of dry fruits and all, like Christmas pudding. Okay, these are the another names of the J.J. Thomson atomic model. Okay, are you understood what is meant by J.J. Thomson? According to J.J. Thomson, how he explained the inner structure of the atom means he compared his atomic model with the watermelon. And first of all, what he said, atom is a hard sphere which contains inside the positively charged particle is spread over the atom. That means in watermelon, how the red color part is spread over the watermelon, same like that only positively charged particles are spread over the sphere and negatively charged particles are embedded in it. Okay, like this he explained protons and electrons are present inside the atom. This experiment or this model what we can call J.J. Thomson atomic model. But unfortunately, this theory or this model is failure. What is the reason behind that? He does not explain how the protons are neutralized the electrons. The whole atom is neutral. He also said the point, the whole atom is neutral. Neutral means what? Protons equal to electrons. When the neutrality will come, when there is 10 protons, then it must be equal to 10 neutrons. Then what happened? Both are cancelled, the whole atom is neutral. But he does not explain how protons are neutralized by the electrons. That is the main drawback of the J.J. Thomson atomic model. He doesn't explain the neutrality. The second point is nothing but there is one more important subatomic particle, neutron. He doesn't discuss about the neutron because that time there is no discovery of the neutron also. Okay, this is about the first atomic model, that is nothing but what ma J.J. Thomson atomic model. J.J. Thomson atomic model. Okay, we will discuss the next atomic model in the next class. Hope you all understood what is the discovery of the neutron and what are the properties of the proton, electron, neutron and the atomic model J.J. Thomson. Thank you so much.